If A is given by this 2 by 2 matrix, our goal here is to find the inverse. Remember, for a square matrix, the inverse will be the same size, so it too will be 2 by 2. And also remember, solving for an inverse matrix is the same as finding the solutions to an augmented matrix. So the first thing we should probably do here is turn this into an augmented matrix, where we have the same coefficients on the left-hand side and the identity matrix of the same size on the right-hand side. And now our goal is to turn the left-hand side into an identity matrix. So we're trying to make the left-hand side look like the right-hand side. But of course, as we use Gauss-Jordan elimination to do this, the right-hand side will change and become our inverse matrix. Of course, as always, our first step for Gauss-Jordan elimination is to get a 1 in the top left corner. So the first thing we're going to do is divide row 1 by 3. Notice how when we divide the first row by 3, there are two first rows. The first row on the left-hand side of the augmented matrix and the first row on the right-hand side of the augmented matrix. Make sure you divide both by 3 in order to get to the right result. Now that we have a 1 in the upper left-hand corner, our next goal is to make that 2 a 0. Remember, there are many paths you can take to the same answer. However, the one I will be taking will be to divide the second row by 2 first. Now what I'll do is I'll multiply the first row by -1 and then add it to the second row. This will result in a 0 in the bottom left corner, which is exactly what I wanted. Of course, as always, be careful when adding these fractions. These are things we learn in elementary school, however, they still kick us in the butt from time to time. In order to get to the identity matrix, I need to get 1s in the diagonal. So I have to make that -1/6 a 1. So what I should do is multiply the second row by -6. I want to take a second to point out how we have only looked at the left-hand side of our augmented matrix. Our goal is to make that side an identity matrix, while the right-hand side is kind of ignored. It's just along for the ride. Whatever happens to it, happens. Alright, back to the game. So all I'm going to do now is get rid of that 5/3 in the top right corner. So what I'm going to do is I'm going to multiply my second row by -5/3 and then add it to the first row. So now you see we have a 0 in the top right corner. If we take a step back, we can see that on the left-hand side of our augmented matrix, we have a 2 by 2 identity matrix. And on the right-hand side, what we have is a matrix that is a product of Gaussian elimination. This right-hand side matrix is our inverse matrix. So what is A inverse? It's this right-hand side matrix.